Hello student, in this video I'm going to start with the forecasting techniques or models regarding the forecasting idea, and this video will continue in more than 2 or 3 videos. Regarding the forecasting, I'll try to cover basic things as much as possible through this PPT. We know that many types of forecasting models that differ in complexity and uh, an amount of data and way they generate forecast. So there are various techniques or models might be available in literature, which will obviously differ in complexity, means how they analyze the data and how much amount of data they take to analyze the data, and how they are in their way to generate a forecast. That is also means what is their output. That is also different in different kind of forecasting models or techniques or scenarios that has been discussed in various literatures till now. Forecasts are very rarely perfect. Forecasts are more accurate for group data than for individual items. Forecasts are rarely perfect, but whenever it is perfect, then it will be more accurate for group data than for individual items. Forecasts are more accurate for shorter than longer time periods. Basically, uh, there are various types of forecasting methods are here. First, you need to decide what needs to be forecast, level of detail, unit of analysis, time horizon required in case of what need to be forecast. Then again, there is another part that is evaluate and analyze appropriate data, identify the needed data and whether it's available for evaluation and analyze of appropriate data. Then again, select and test the forecasting model. The cost, ease of use and accuracy must be there. And again, generate the forecast, monitor forecast accuracy over time. Basically, the types of forecast can be qualitative and quantitative. Qualitative, in case of characteristics of the qualitative methods are like based on human judgment, opinion, subjective and non-mathematical. And strength of these qualitative methods can incorporate latest changes in environment and inside information. Weakness can bias the forecast and reduce forecast accuracy. Quantitative method based on mathematics and quantitative in nature. Consistent, objective, able to consider such information and data at one time. Often quantifiable data are not available. In weakness is that often quantifiable data are not available, only as good as the data on which they are based. In case of qualitative methods, or we can say judgmental methods, forecast generated subjectively by the forecast educated cases are here. In case of quantitative methods based on mathematical modeling, forecast generated through mathematical expressions. And again, in case of qualitative methods, not quantitative, in qualitative methods there are also different types. Executive opinion might be there, market research might be there, Delphi method might be there. So in case of executive opinion, a group of managers meet and come up with a forecast. In the strength of executive opinion is that good for strategic and new product forecasting. Weakness is that one person's opinion can dominate the forecast. In case of market research oriented method, uses surveys and interviews to identify customers' preferences. And strengths are good determinant of customer preferences. And weaknesses are like it can be difficult to develop a good questionnaire. Delphi method seeks to develop a consensus among a group of experts. Excellent for forecasting long-term product demand technological. Strengths is Delphi method is a bit of technological other than executive and market research oriented qualitative methods. In case of Delphi method, it consumes some time to develop. That is the weakness of Delphi method. In quantitative methods, there is also different types like time series model. Second one is causal model or associative model. In case of time series model, assumes information needed to generate a forecast is contained in a time series of data. Assumes the future will follow the same patterns as the past. So there are two basic assumptions. Try to understand these two. In case of time series model, we assume that information needed to be generated or information that are going to be inherited or that are going to be forecast is contained in the same information or same timeline of information, or we can say same time series of data. Also, we assume that the future will follow the same pattern as the past. In case of causal method or causal models or associative models, it explores cause and effect relationships, use leading indicators to predict the futures. Housing starts and appliance sells. So forecasters look for data pattern as like they look into the data two part. First part is that historic pattern. Is there any basic pattern involved in that data? Plus, is there any random variations are there or not? Because if the data contains random variation, it will be tough to go, or it will be very easy to say that the data is completely random. Or if it is following more historic, then it will be very easy to forecast or predict the future. Historic pattern to be forecasted, there might be different types of historic pattern might be there in the data, like level long-term average data fluctuates around a constant mean. That might be there in the data. There might be some information that might be revolving around a mean or fluctuates around a mean, around a constant mean. There might be a trend, data exhibits an increasing or decreasing pattern, or might be other wave pattern or other pattern or trend might be there in case of any kind of time series data. Seasonality, any pattern that regularly repeats itself and is for a constant length. So there might be exists some pattern which repeats itself after certain amount of time or regularly for a constant length of time. There might be cyclic pattern also, pattern created by economic fluctuations like that. There might be cycle involved in case of any data might be involved. Random variation cannot be predicted. That is why if you might want to also know that there exist any random variations in the data or not. If the data consists most of the random variations, that it might not be well for prediction. Here you can see different patterns of time series data. Level or horizontal pattern is that where data follows a horizontal pattern around the mean. That here you can see this is quantity, and this is time. And again, this is trend pattern, whereas this is the quantity time which follows the increasing trend like this. But here it is following in a horizontal pattern around the mean. But this is data is progressively increasing. Seasonal pattern is like the data exhibits a regular repeating pattern like this. This is a regular repeating, or we can say waveform like. So this is a seasonal pattern. And cycle is that this is there is a cycle of this data increases or decreases over time. So though it is like this one, but this is more frequent, or this is more explicit than this one, but this is like a cyclic. Okay. So naive approach is that the forecast is equal to the actual value observed during the last period. Good for level patterns. That is, forecast is equal to the actual value observed during the last period. Good for level patterns mean the forecast mean ft plus 1. That value will be almost the past value of that same data. equal to the actual value observed during the last period, or you can say in the past. Simple mean is that the average of all available data that is good for level patterns. That is, this is also good for level patterns. Level patterns are like this one. Okay, this is also good for level patterns if you go for simple mean, because that data might be revolve around the mean. So you might take the mean of that actual data by dividing the n number of samples or n number of data or n number of inputs and sum up by averaging them. Then that will be your forecasted data that is following the simple mean. So it will be good only for level kind of or horizontal kind of pattern of the data. There might be also moving average. The average value over a set time period in the last 4 weeks. So the average in case of simple mean, it will take the mean of complete data, but in case of moving average, it will take only a certain amount of time. The average value over a set time period, it might be last 4 weeks, it might be last 2 days, it might be last 1 year, like that. Its new forecast drops the oldest data point and adds a new observation, more responsive to a trend but still lags behind actual data, because it is following a mean kind of thing. So this will be also good in case of a horizontal pattern. Weighted moving average, all weights must add to 100% or 1. So to the actual data for at any time, there might be some weight associated with it. Here CT is the weight adding with the actual data, and then it will give like all weights must add up to 100% or 1, that is CT 0.5 might be CT minus 1, 0.3, CT minus 2, 0.2. So how you give the weight, that is your up to your method. Weights add to 1, but summation of all these constants should be equal to 1. Allows emphasizing one period over others. Above indicates more weight on recent data. So it allows emphasizing one period over others. Differs from the simple moving average that weighs all periods equally, more responsive to trends. So in case of using weighted moving average, you can put some emphasis on a specific period and which by providing more weight on that data, and also you can differ from simple moving average that weighs all periods equally. So other than, you can go for simple moving average also, like the previous one, but here the difference is that you are giving a weight with that can be also done. There is another one, that is exponential smoothing, most frequently used time series method because of ease of use and minimal amount of data needed. So here in case of exponential smoothing, you can use small amount of data, then also you can predict that thing. Needs just 3 pieces of data to start: last period forecast, last period actual value, and select value of smoothing coefficient alpha between 0 to 1. So that is the main point here. Smoothing coefficient that will be added in the equation, that is smoothing into AT plus 1 minus alpha into FT. FT is the last forecasted value and AT is the actual data for that last period. So if no last period forecast is available, average the last few periods or use naive method. So in case of if you don't have the last forecast value, you can use the average last few periods. Means whatever periods you have, whatever the time series data you have, you might take the average here, and again or you can use the naive method of naive method is like this one. This is the naive method. Just take the past value in case of this exponential smoothing. Higher alpha value means suppose 0.7 or 0.8 may place too much weight on last period's random variations, so which will give you more weight on the last value. So you can say that smoothing, that is why this is called smoothing, you are giving more weight on the last guessed or forecasted data, which will help you to focus more on now. If the value of alpha is less, means you are giving less amount of importance in the last data because the forecast was not that good. That type of scenario can occur. So here you can see time series problem. Determine a forecast for periods 7 and 8. Suppose these are the periods 1, 2, 3, 4, 5, 6 and 7. So you need to forecast the 7 and 8 using the exponential smoothing. So second period is moving average, fourth period moving average, and second period weighted moving average with T1 weight 0.6 and T minus 2 weighted 0.4, exponential smoothing with alpha 0.2 and period 6 forecasting being 375. So try to go through this. So I'll try to so this is 2 period moving average, 4 period moving average, again 2 period weighted moving average. So this problem will be done in the next video. I'll try to go through this one in case of time series analysis. Till then, if you have any confusion whatever we have discussed till now in this video, please let me know, or if you want to add something, then also let me know. We'll try to resolve those things over Google Meet. Thank you.